In this lesson we study another application of rational equations, and that's work problems. The idea behind these work problems is that it will take a certain amount of time for a person or a machine to do a job, and a different amount of time for another person or machine to do the same job. So if the two of them or more are working together on a project, the job should get done more quickly. So kind of similar to rate times time equals distance, here we would know that jobs per hour times the number of hours equals the jobs done. And we're going to go ahead and use a table to help us organize these type of problems. So we're going to jump right in. We're going to do two examples and look at some important concepts as we work through these examples. The first one says a large water tank can be filled in 8 hours of continuous pumping using pump A. If a smaller pump B works with pump A, it takes only 6 hours to fill the tank. How long will it take pump B to fill the tank? So here we're looking for amount of time it will take pump B to fill the tank. So that's going to end up being our variable. So what we're going to do is we're going to set up a table here, and our table is going to deal with pump A, pump B, and then working together. And in these tables we're going to have a couple headings. We want to know how long it takes pump A to do the entire job, how long it would take pump B to do the entire job, and then how long it would take them together. And so we can fill that in. We'll add to our table in a minute. But we know that pump A, it would take 8 hours to finish the job. We're actually trying to find how long it will take pump B to finish the job, so that's going to be our variable, that's x. But we know working together, it's going to be 6 hours. Now here's an important concept that's really going to help us figure these out. We want the amount of job finished in 1 hour. So how much of the job is getting finished in just 1 hour? So if it takes 8 hours for pump A to finish the job, that means it's just going to be the reciprocal of that. It's going to get 1/8 of the job finished each hour. For pump B, we don't know how long it takes, but it's going to be 1 over x jobs per hour. And then together, if it takes 6 hours together, it would get 1/6 of the job done in 1 hour. And that's an important concept to understand. So all we have to do now is make an equation out of this and solve it. So in 1 hour, pump A gets 1/8 of the job done. Pump B, working together with it, so we're going to add the amount it pumps out, which is 1 over x. That's going to be 1/6. So after 1 hour together, they're getting 1/6 of the job done. So really this is saying the amount pump A gets finished in 1 hour, the amount pump B gets finished in 1 hour is going to equal the total that gets finished in that hour. And now we're just solving a rational equation. Remember, to solve these rational equations, we're going to go ahead and multiply by the least common denominator. And so we see here with 8x and 6, we may think 48x, which would work, but the least common denominator is 24. So we're going to multiply both sides by 24x. Distributing, when we multiply here, the 24 would reduce with 8 to give us 3x. Multiplying by the second one, the x's reduce, and so we're left with plus 24. And on the right side, when we multiply these, the 6 and the 24 reduce to 4, so that's 4x. And now we just have a nice simple equation to solve. In fact, it's really simple. We're just going to go ahead and subtract 3x from both sides. And we get x is equal to 24, which means it would take an entire 24 hours for that pump B to fill up the tank. So this is 24 hours. But when A and B work together, it would only take 6 hours. Our second example here has to do with painting. Teresa and John are going to work together to paint their living room. John can paint it in 8 hours and Teresa can paint it in 10 hours. How long will it take them to paint the room if they work together? So same idea as the last one. We have Teresa, John, and then working together. We're going to go ahead and check out what they can do, how long it takes them to do the whole job, and then we're going to figure out how much they finish in 1 hour. And so Teresa, she can do it in 10 hours, which means she can get 1/10 of the job done in 1 hour. John could do it in 8 hours, which means he could finish 1/8 of the job in 1 hour. And we want to figure out how long will it take them together. So that's our variable, that's x, and they're getting 1/x done per hour. And now what we do is we add these together. We have the amount Teresa can get finished in an hour plus the amount John can get finished in an hour is going to equal how much they both can get done together in an hour. And we're going to solve for this. Our common denominator would be 40x. So we'll multiply both sides by 40x to solve this rational equation. When we distribute here to the first one, we would get 40x over 10, which is just 4x. Multiplying by the second one, we get 40x over 8, which is 5x. And over on the right side, when we multiply, the x's would reduce and we get 40. So solving this, we get 9x equals 40. Dividing both sides by 9. We obviously get 40/9. In this case, it would be helpful to write it as a mixed number so we see how many hours that would be. So 40/9 is 4 4/9 hours. It would take them, if they work together, to do that job. So those are work problems. Again, they're really important concept here. If you have the number of hours for the entire job, you just do 1 over that to how much they finish in 1 hour. And then combine the different people or machines working together to add up to what it would be working together.